Welcome to the Big Data Show. Today I am going to start a brand new tutorials or course on one of my favorite framework which is widely used in data engineering domain. So from last 3 years, I am mostly working on streaming pipeline and I have written a lot of articles on Mediums and LinkedIn about the frameworks like Apache Kafka, Spark Structure Streamings, Kafka Connect. So I have realized that in data engineering, Kafka use of Kafka is increasing a lot. And I have also realized that data engineers don't understand Kafka in that much depth. To cover this gap, I am creating this course. I hope you will like and learn from it. Okay, so I am calling this course as Kafka for data engineers. And I have divided this course into multiple modules. And today we will be starting our first module, which is Introductions to Apache Kafka. Inside this first module, we will focus on firstly on lesson 1.1, which is overview of Kafka. Here, firstly, I will make you understand the real use case in data engineering domain where Kafka is involved. I will demonstrate one real use case. Okay, we will try to understand the use case. After that, we will try to understand what is Kafka. Cool? And once we have some introductions about Apache Kafka, we will try to understand what is event and what is an event streaming platform. Okay, and these all things are correlated. Then we will also try to see that why Kafka is used predominantly in a data engineering world. And what is the fundamental difference between Apache Kafka versus traditional messaging queue like RabbitMQ, ActiveMQ. When we will try to discuss this concept, we will also try to understand that what is a messaging queue and what is a pub-sub model, like what is publisher and subscriber model. Then in lesson 1.2, we will try to understand the basic terminology and basic key concept used in the Apache Kafka. We will try to understand what is producers, what is consumer, like what is brokers, what is a cluster, what is a topic, what is a partition in the topic, what is offset in the partitions, what is a consumer, what is a consumer group, and what is the use of zookeeper in Kafka. So these are the basic terminology which is often used in when we are working with code base involving Apache Kafka. Once your understanding about all those terminology is good, it will be easier for us and it will be easier for you to understand the different concepts of Apache Kafka. Cool? So without wasting time, let's try checking the first thing, which is the data engineering use case which involves Apache Kafka. So I have worked on the similar type of project from last 2 years. So I am giving one example which is used in most of the e-commerce industry like Amazon's, eBay, Flipkart, Walmart, and this type of company, right? So let's try to understand this particular use case. So here, if you can see that, let's suppose there are multiple sellers, okay? So seller will try to sell some items by visiting seller.amazon.com, right? They will go to seller.amazon.com. Okay, so seller will try to onboard some item, right? So they are trying to onboard some item. They will go to this particular website. Then from this website, there will be some backend applications running, which will load this data to some database. For now, let's just consider that this data is being loaded to MySQL. Cool. So you might not be knowing CDC. Okay. So, but there is a concept called change data captures. And what that can do, that can read the logs, that can read the write ahead logs of your database, and that can take, using CDC, you can actually read the data from your databases, and then you can transfer it to some messaging queue or even the streaming platform like Apache Kafka. I know you might not be knowing CDC, but for now, just understand that seller is trying to onboard some items on Amazon Marketplace, and they are going to seller.amazon.com. And from seller.amazon.com, there is some backend systems, and that backend API will actually load the data to some transactional databases, something like MySQL. On top of MySQL, there will be some CDC implemented, like DBGM, okay? And that CDC will capture the data from database and load this data to Apache Kafka. So this is a typical example of Kafka producers applications, where some user is trying to load data to some website. From that website, data is actually getting loaded to the some databases, and from that databases has CDC implemented. So whenever there is some change in that database, that will actually capture and it send it to some messaging queue like Apache Kafka. Cool. Now you will say, Ankur, where are data engineers involved here? So data engineers are involved after this. Okay. So let's suppose your application teams has set up the CDC, and from your MySQL database, they are sending this data to Apache Kafka. After that, as a data engineer, your work will be to write the consumer application in most of the times. You can write your consumer applications using some real-time streaming framework like Spark Structure Streaming. That is one of the framework which is predominantly used in the industry. You can use Apache Flink. You can even use Kafka Connect, right? So you will take this data from Apache Kafka and you will actually subscribe to Kafka topic. We will understand what is Kafka topic. But for now, just understand as a consumer applications, you will read data from the Kafka and using some streaming framework like Spark Structure Streaming or Kafka Connect. Okay. And then using a Spark Structure Streaming, you can enrich this data. So let's suppose when you are reading, like getting this information from MySQL, then let's suppose your structure was something like that. Item ID, perfect, or item name. Cool. Let's call 1, 2, 3. And let's call t-shirts. T-shirt black. Well and good. Let's suppose you receive this information from your MySQL server. Now, what as a data engineer, your work is to enrich this data. So you might be having some databases of seller, right? Some database of seller. So let's call this as a seller table. And this data might be stored in some databases, like let's suppose it is stored in some Postgres, or it might be stored on MongoDB. You might be stored on some Elasticsearch. Well and good. Now, in your Spark Structure Streaming, when you will read the data from Kafka, you will receive that information like this, right? Only two columns, item ID and item name. You will take this data and let's suppose you also have seller ID. Well and good. Let's suppose seller ID is 334. So you will have your incoming data has three keys and their corresponding values. In Spark Structure Streaming, what you will do, you will actually like enrich your data. Like you will use the seller ID and hit your Elasticsearch or MongoDB. Well and good. You will hit the MongoDB and get the other information of the seller. Like you already will be having some rating for that seller. So let's suppose you are having rating table, right? So from that rating table, you will go and check the seller ID. So okay, seller ID, comma, rating. So from your database, you will go and search for seller ID 334. And let's suppose you will find rating is equal to 4. You will take this data and enrich your data. Now, your data will be contains one more columns after your Spark structure streaming. It will contains one more column like seller rating, and you will say 4. And this seller rating information is actually coming from some other databases. Okay, so you are reading this data from Elasticsearch or MongoDB or even Postgres, and where you are writing all this code, you will be writing all this code in the Spark structure streaming. Like your Spark structure streaming applications will act as enrichment tools where you will be writing some transformations like enriching your data. And once your enrichment is done, then this data can be loaded to S3. Okay, if from AWS S3 you will use something like Athena and Glue, you might not be knowing about Athena or Glue. So let me help you in a very simple terms. As a data engineer, your work is to read the data from Kafka, enrich this data, and then load it to some systems which can be further utilized by your data science or even your ML engineers or even your data analytics teams. So in your S3, you will load the data inside Parquet format or ORC format. And on top of that, you will keep one query engine, which is AWS Athena. And for using that query engine, you will use Glue crawler, and then you will also use metadata management. Okay, so in metadata, you can keep the schema, right? You can keep the schema like what is the, is it string or is it integer? And like you can use this AWS Glue. You might not be knowing, just for now, just imagine it. Like Glue can help you to manage your metadata, and your Athena will become your query engines. And using Athena and Glue, you can read data from your S3. Like your data science teams can start firing query. Okay, they can write this is like SQL query which they can write on Athena, and they will get the data in the table format. Now your data science team can act on that data. So as a data engineer, I hope you have now understood that where Kafka is predominantly used. Like there will be some producers which will take the data and load it into your Kafka topic in Kafka. From Kafka, you will be writing some consumer applications using real-time streaming framework like Spark structure streaming, Flink, Kafka Connect, right? And then you will write some transformations like enriching your data, which we have just explained. And then you can even load this data to AWS S3, or if you're using GCP, then Google Cloud Storage, to any distributed storage, right? You can even send this data to another Kafka topic, which can be further utilized by some other team. Cool, right? And you can even use Kafka Connect applications. I will make you understand what is Kafka Connect. And you can use this data and load the data into like in a data lake format using AWS S3 or GCP cloud storage if you are using GCP. And you can even load this data in a very new data design, which is Lakehouse. So right now, Lakehouse is very much famous. You might not be knowing, but just think like when data engineering world started, it started with databases. Then it moved to data warehouse. Then it moved to data lake, okay, which is right now predominantly built on top of S3 or GCP cloud storage or any other distributed storage. Now there is a concept of lakehouse, which combines the good thing about data warehouse and data lake. And in the lakehouse pattern, there are three different open table format, which is very much famous right now: Apache Iceberg, Apache Hudi, and Delta tables, which is made by Databricks. So you can even use Kafka Connect applications and load these things into some open table format, okay, which can be used by some other teams. I hope you understood a basic use case of uh, Kafka where data engineers are involved, right? I hope you are clear. So just to let me revise it a little briefly. Like there will be some producer which will load the data to Kafka, and after that, as a consumer applications, you will be writing code in real-time streaming framework, and then you will be loading, enriching your data, writing some transformation, loading into some further systems, which will be further utilized by some other teams. So I hope you understood what is the basic use case now. Let's try to revise the use case which we have demonstrated just now. It is very important to understand this in depth. Then only you will feel the Apache Kafka, and then only you will able to use in a data engineering domain. Cool. So the first thing that we have seen is the Kafka producer applications, right? So the first thing was Kafka producer application, correct? There we have seen that there was one application team whose job was to load the data, right? Load the data to to Kafka. Then in the previous use case, we have seen that data engineers teams came into picture for enriching data or applying some business transformation. And how we have done that? We have used Kafka as source, right? And then we have used two consumer applications, like consumer application. We have written two consumer application, one and two. This consumer application was written using Spark structure streaming, whereas this consumer application was written using Kafka Connect. Well and good. And we have seen that after using this, like using real-time streaming, like a Spark structure streaming or Kafka Connect, and then using Kafka as one of our source, then we were applying the business transformation, and then we were loading data to another Kafka topic or AWS S3 bucket, or we can even write to some new technology like Apache Hudi, Iceberg, like in a data lakehouse design patterns. So this was the use case of data engineers, right? Which involves Apache Kafka. Now, one thing I want to make you very clear that why Kafka? In a very simple term, we will discuss about it in a greater depth, but let me just give you one line. So Kafka is predominantly used in data engineering world because it decouple producer and consumer application. What does this mean? This means that Here, producer application will write the data. This is one broker, this is one machine, machine 1, machine 2, machine 3. Here producers, like any applications team, will produce the data to Kafka topic on their own speed. And there can be multiple consumer applications which can subscribe to the Kafka topic, or in a very layman terms, can read from the Kafka topics independently. This producer and consumer speeds are not related. They are writing the data to one transient systems. Like producer is writing data to one transient systems, which is Kafka. And there are multiple consumer applications which can run or read the data in a parallel way or independent of each other, right? So this Kafka act as a transient database as a messaging queue where you can store your data during like in for some duration of time. You will define your retention period and retention size, which will again talk in depth what is retention period and what is retention size. But for now, you understand that data will not be lost when a consumer applications read the data. Like if we are writing data to Kafka and if Spark structure streaming applications read the data, it does not mean that data will be lost for Kafka Connect applications. Like data will be always be there until the retention period or retention size of which is defined in this particular Kafka. And this was the major reason why data engineers are choosing Kafka, because you can store the data for some duration of time and the multiple teams can plug their own consumer applications and can read it independently. I hope you have some gist right now that where the Kafka is being used predominantly in the data engineering world. And now I hope you are ready to learn many things, right? And I hope you are ready to learn everything in deep way. And as we have already told that I have divided this course into multiple modules. And for coming days, we will be talking on module 1, which is introduction to Apache Kafka. And once that complete, then we will go to module 2. And in module 1, we have already completed this particular thing, right? Data engineering use case involving Apache Kafka. I have just demonstrated using pictures and using diagram that what is and where is Kafka used in data engineering world. With coming videos, let's start learning what is Kafka, what is event streaming, what is messaging queue, what is PubSub, what is the difference between Kafka and traditional messaging queue. I hope at least you have some idea now that in Kafka, whenever the data is getting stored, it is independent of producer and consumer. There is a decoupling of producer and consumer, and data is not getting lost when one consumer is reading it. In traditional messaging queue, this used to happen. Like producer used to produce the data, and whenever one consumer used to read the data was getting lost from that particular messaging queue. But this does not happen in Kafka. Data will be always stored, and there will be decoupling of producer and consumer. They can read and write independently of each other. Well and good. Like, and if you want to understand in a more layman terms, just consider Apache Kafka as a store, as a distributed storage, where you can store the data for some duration of time. But that's not only use case of Kafka. There you can even like use this as an event streaming platform. You can process the data. So there are many things, but for now, just to keep your heads very light, just try to understand that in data engineering world, most of the times Kafka will be used as messaging queue, where data will be stored for some durations of times, not for permanent durations like normal tables like Postgres, MySQL. And there will be some publishers or some producers producing the data, and there will be multiple consumers who will be consuming the data. I hope this is clear. And then in the lesson 1.2, we will understand different key concepts like producer, consumer, broker, clusters. And partitions, partition offsets, zookeeper, consumer group. I have planned 5 modules. I am only talking about module one for now. Let's hope we keep learning and we keep exploring multiple good things. I hope you will watch the next video. Until then, keep learning, keep practicing, and if you have liked this video, please do like the channel and subscribe to the channel, and also share with your friends who are learning uh, Kafka in a greater depth.